Hi, today's talk is about writing a scraper as a state machine using Playwright, Kafka, and XState. So a little bit about me. My name is Alberto Schiabel. You can find me online at Zecomino. I live in Venice, and I'm an open source software engineer at Prisma.io. I'm also a freelance consultant specialized in Node.js and TypeScript, and I'm interested in functional programming and type-safe languages. So today we'll learn about how to perform browser automations with Playwright. We then dive into funny state machines with XState and understand how they allow us to model and visualize complex logic and reactive systems. Moreover, we'll keep the state machines definitions and their implementations separate, allowing us for separation of concerns and ease of testing. And moreover, we'll introduce Apache Kafka to perform loose coupling between microservices, implementing in our motivating example, which is a Glassdoor scraper written in TypeScript. So this scraper, what does it do? It's given some user credentials. It logs into Glassdoor.com and it downloads the user's details like their name, their current company, the current job title, and the user's resumes. It's both unit and integration tested and it runs on Node.js. All right, let's start with Playwright, a cross-language browser automation framework. It started out as kind of a fork of Puppeteer, which most of you are probably familiar with. And it's built on top of the experience that the team accumulated with that. So Playwright started by the same team that originally developed Puppeteer at Google. Eventually, all these people from Google migrated to Microsoft. And they added cross-language support, so you can write automations in Node.js or Python or other languages. It's cross-browser. You can support both Firefox, Chrome, WebKit, and supports fancy methods for integration testing and end-to-end testing, like allowing you to wait for a certain event to happen without having to resort to weird set-time hooks. And it's also more recent. It's from 2020. So let's start immediately by looking how it will work in practice. So in this case, you see I'm using Firefox. We're launching the desired headless browser instance. And this is like opening the browser in your desktop. And then we specify a new context. This is like opening a new incognito window with a fresh session. And we can even specify settings like the locale and the time zone where the browser would use. And always remember to free up the Playwright's resources when you're done with them to avoid memory leaks. So a nice trick is defining a dispose function that you can call at the end of your script or when you've caught some errors. We can also see how to open certain URLs. This is fundamental for a scraper, right? So we can use the context from before to create a new page. You see, we specify the URL we want to go to. We're going to use that later. And we can also tell Playwright to give up any operation after a certain amount of time. We don't want to wait for eternity. And this is how we can do that. We take the page from before. We use the goto method to go to the URL. And this is like just navigating with your browser. It can fail in certain cases, like when you provide an invalid URL, when the SSL certificate has expired, or it might return null in some other situations, like when opening about at blank. The funny thing is that when you hit HTTP error codes, it won't fail. So it's up to you to check the status code and to perform some logic in case of HTTP 404 or 500. And again, always remember to close your page when you're done. This is how it will look like now. How can we fill this form? Well, we just start locating the input element here, you see, and we provide the email, we inject the email into the form, and then this is the crucial part. We're expecting some API calls to happen under the hood, and they will load a new page where we can write the password if our email is correct. So we might have race conditions, and Playwright's documentation say that it's important to use promise.all in these cases. So we are both waiting for no more network requests to happen, and we click on the submit button. And as you see, I'm using the CSS selectors, the standard CSS selectors for locating the button. And then we can also do something like checking whether a certain text selector is present in the page. I'm using the isVisible method in this case. And it's important when you use text selectors, which shouldn't be your first choice, to not use quotes. Now we can handle, we can insert the password. Again, this is very similar to before. We are now using the wait for navigation method because we expect a full page change when you are submitting the password. And we can also try to see whether we are properly authenticated or not. And the cool part is that if we keep using this context and passing this context, this Playwright context around, we will not be considered authenticated in the system. There are other useful methods, like we can wait for a specific HTML element to appear. We can use this wait for selector method. We can gather an array of element handles, and each handle, for instance, allows us to click on it. And moreover, we can download files. So let's say these are all the links for downloading resumes in the Glassdoor page. We can wait for the download event, and we can click on those links. As usual, I'm using promise.all. And what we will get is a readable. This is a standard readable stream for Node.js. You can do whatever you want. You can store it into buffer. You can retrieve the PDF from it. And it can be null if the download is failed. So in case the load fails, you won't get an error. You will just get null. All right, let's move on with XState now, a finite state machine framework for JS. So what is XState? It's a TypeScript library which we can use to model and execute finite state machines and state charts. These are fancy words, but are concepts that are being used since the 40s. So let's get more into it. Finite state machines formally describe a system, and that system can only be in a single state at any given time. And they are made up of a set of states that needs to be finite, a set of finite events, a unique initial state where this machine starts, and it can have 0 or more final states, which is when the machine stops running and you can just do something after it. It also supports deterministic transitions between state, which is what allows reactive systems to evolve and to move between one state and the other. And the evolution of finite state machines is state charts introduced in the 1987. They support guarded transitions, which means you can transition between states only if some condition applies, some Boolean predicate is satisfied. You can have parallel states, which are states that contain some substates, and these substates can be executing at the same time. And it also supports actions, which are side effects. Imagine calling an API when moving from a state to another. And the cool part about finite machines and state charts is that they abstract away the logic of your system and it decouples it from the implementation. They're excellent for prototyping. You just define the states and transition rules without defining an implementation. You can set up your unit tests and you're fine with it. And you can also have visualization of the logic of your application. For instance, XState provides a visualization library. Let's see an example here. We use the create machine method. We define a finite state machine. We see the states here, the initial state, which is idle. And when the start event is received, we have some guarded transitions. So when the even condition is satisfied, we move to the even state, which is defined right down here, and it's final. And when this predicate is not satisfied, we move to the odd state. And this is the visualization you will get with a VS Code extension for XState, for instance. And this is how it will look in practice. When we need to execute the machine, we will need to define the guard explicitly. So before we only had a string to identify it, now we have an actual method. We are receiving something like a context and an event. We'll explain that later. And we are using the interpret method, and we are explicitly sending an event via the send method. All right, so a bit more about states. We have seen initial and final states. We have briefly introduced parallel states. XState also supports compound states, which are in general states that can contain other child states. And these states just model how our reactive system evolves through time. For instance, our scraper can be initially idle, so it hasn't started scraping yet. It can be authenticated, and once authenticated, it can perform concurrent tasks like scraping the logged users info, downloading the resumes. Those can happen in parallel. And at some point, it will be in a final success or failure state. So let's see how events look like. Events are triggered. Events are what triggers a state transition from one state to the next state. They are defined by a type property, as you can see also in the code, and optionally they might have some additional information, which can be used to share data between one state and the other. And they can be sent around via the send action. We've seen the CTX before, the CTX argument before in a function, defining the guard. So what is that? Well, context is what allows us to keep track of quantitative data, which is like generic strings, numbers, arbitrary objects that would otherwise be lost between state transitions. So it is some sort of persistent storage for the finite state machine execution. We can use it, for instance, to store credentials, to log into Glassdoor or a Playwright instance, like the context, which is kind of odd, yeah, because we have used the context both for Playwright and XState, but it is what it is. Those are the names used by the respective libraries. And for XState, the initial context can be defined in the machine definition. We can see that right here. And it's updated via actions. So what are these actions? Well, those are fire and forget functions triggered by state transitions. They are defined in the machine declaration in the invoke.src property. And once implemented, they can perform side effects like logging or making API calls, like calling the Glassdoor, scraping Glassdoor pages. And there are three main types of actions: entry and exit, which are executed when entering and exiting a state, and then the standard transition actions, which happen when transitioning due to an event. So we will focus on asynchronous actions because our scraper functions for Playwright are all asynchronous. And these asynchronous functions are based on promises. And let's take a look at the example here. So we have the init browser state. We are invoking a function with the invoke property. And the function is called initialize browser right here. It's an asynchronous action to be defined later. When is that defined? When we call machine.withConfig, just like we did for the guards. When the promise or when this action succeeds, we enter the undone part here. And in target, we can specify the next state. And with actions, we specify what happens when we immediately before we transition to that state. In this case, we are modifying the context. So this assign utility here is a pure function. It has access to the current context and the event that caused the transition. And we can, for instance, update the browser property, so context.browser, using the result of the event, accessible via event.data. And when we are, the promise rejects, we enter this on error area here, and we send an event called fail init browser. And this event is then defined down here, where we see it just targets the failure final state. And the implementation will look something like this. We have this with config, just like before, and we are plugging that in the services. So actions, the action implementation for actions is defined in the services property. And these results of the initialize browser function, as you can see, can be accessed via event.data. All right, this is what we need to know about XState. Of course, there is much more, but let's take a brief look at Apache Kafka. So first, let's start with how that should look like in our system architecture. So we start with some sort of producer here. This is like a scraper job producer. It provides some credentials to access Glassdoor, and it publishes them to a Kafka broker. In particular, we publish them and we categorize it as input Glassdoor. So this is a message of the input Glassdoor type. Then we have our Glassdoor scraper here, which performs the actual work, and it subscribes to these input Glassdoor messages. It pulls them from Kafka. It runs the state machine, and we can define that in a separate module. For instance, in the demo, it's defined in this Glassdoor scraper FSM module. And then once we reach the final states, you can publish the results in either the, this should be output success Glassdoor, the green one. Yeah, it can publish them either to the success queue or to the failure queue. So more in detail, Kafka allows us to publish and subscribe to streams of messages, storing them for a configurable amount of time in what is called a broker. Streams of messages, which are like clustered by the same category, are called topics. And producers send messages to a topic in a broker. Brokers receive them and store them for a certain time that is configurable. And consumers read those messages, and they can decide whether to read them from the first message ever received from the broker or from the next message received. Kafka keeps producers and consumers decoupled from each other, and it's a pool-based queue system, which means that if you have very slow consumers, because they're for instance, you might have several scraper jobs starting, so you might receive several authentication credentials. But scraping takes some time. It might take a minute or so. So using Kafka prevents you from having problems with this kind of divergence in velocity. And we're going to use the Kafka.js library. So this is how you will initialize that. You will define the Kafka server in the broker property, and you can define a unique group ID. Clearly, Kafka has a lot of complexity under the hood. The time today doesn't really allow us to go deeper into that. Then we define the consumer and the producer. Those are not initialized yet. The consumer must have a unique ID, and the producer can decide whether to automatically create a new topic if it doesn't exist yet. And to connect, to initialize them, we need to call the connect method. Again, we should always dispose our resources when we're done using them. We can consume messages by subscribing to a topic with the consumer. As you can see here, the consumer.subscribe, but that doesn't actually start processing them. To process them, you need to call consumer.run and then define each message callback. The most useful parameter you will need here is message. Topic is only useful when you are subscribing to several topics at once. But there are cases in which your consumer is so slow that you need to explicitly tell Kafka to pause some execution or to submit a heartbeat. We're not getting into those details right now. And for producing messages, it's quite important to have unique IDs as the key. Like messages are a key value tuple. If you use these unique IDs for a key, you can then use them to correlate the messages you receive in your Kafka dashboard. For the value, you have several serializations that are available, like Apache, but we're gonna keep it simple. We're just gonna use stringified JSON, and we're using the producer.send method. By default, it asks us to produce more than one message at once. We're just producing a single one here. And this is it. The demo, I have already recorded that because I figured that we might risk being a bit out of time. But so you're gonna see that here. But let me conclude with a few takeaways from this talk. So what have we seen so far? Playwright provides a great developer experience. It has learned from the mistakes of Puppeteer, or from like the ambiguous methods that Puppeteer offered. And it's great for browser automation, testing, and scraping. Then finite state machines and state charts allow us to separate the definition of a system from their actual implementation, which also is great for testing. Like we can have unit tests that run in less than 1 second that specify the overall logic of the system without declaring any action. We've seen that XState accommodates complex use cases with conditional logic, nested parallel states. We use those in the Glassdoor motivational example. So I encourage you to check out the demo. And the problem of XState is that if you're not used to it, it requires a mental shift from imperative to declarative programming. And it takes a while to get to learn it and to get started with it. Hopefully this talk will allow you to be faster to pick it up. And finally, Kafka is a great tool to start building distributed microservices. You can start with very simple configurations and then evolve as you need. It's really complex under the hood. I encourage you to study it if you haven't. And also left a few additional materials. All right, thank you so much.